Okay, this is going to be a screencast on dimensional analysis. Dimensional analysis is a way we keep track of numbers when we want to convert from one thing to another. We use it quite a lot in chemistry and even more so in physics and in the higher levels of math. So, best way to kind of learn this is by example. So, for example, how many inches are in 2 feet? Now, some of you may already know how many inches are in 2 feet and already thought about the answer, but the conversion factor you would have to know to be successful in this question is what is the conversion between feet and inches? And we know that 1 foot is equal to 12 inches. And since you have 2 feet, that means you multiply your inches times 2. I'm sure some of you have thought about it in your head already, but there is a system that we set this up so that we can convert any number. The way we do it is this. I will write my given, 2.0 feet. I'm going to hit a multiply fraction bar. Now this fraction bar will be populated by my number and my units. Since I'm looking for inches, my inches will be on top of the fraction bar. And since I'm given feet, my feet will be in the bottom of the fraction bar. The reason why I do this is because I want my units to cancel out. I want feet to cancel out with feet, so dividing feet divided by feet will cancel out and I'll be left with inches. I know my conversion, 1 foot is 12 inches, so I'll write 1 foot and 12 inches here. And since I now have my given in the proper area, here's my conversion factor, that's right here. Oops. And I know that my conversion factor is correct because my feet will eventually cross out. And 2 times 12 divided by 1, that'll be 24 inches. So when we're doing dimensional analysis, it's important how we understand this setup. Here's our given. We multiply times a fraction bar. The units we're looking for will be on top, and the units that's given to us will be on the bottom. We always place the units in the proper place to make sure they cancel out. Since I was given feet, my feet will cancel out, and I'll be left with inches in my answer. So let's do a different example. How many feet are in 17 inches? This is not going to be a question that will be easily solved because now we're dealing with fractions. But if we use dimensional analysis, it's really not that hard. So I'm going to use, here's my given, write my given out, 17 inches. Multiply fraction bar. Okay, so since I'm given inches, I'm looking for feet. Here's my feet. I'm going to put feet on top. Inches will be on the bottom of the fraction bar because I have to make sure that they both cancel out. Inches will cancel out with inches. I know that 1 foot is 12 inches. And so there's my conversion. 1 foot is 12 inches. I now can just plug this in the calculator, and it really is going to be 17 times 1 divided by 12. And that's going to be 1.42 feet. So this is probably a question that you cannot figure out in your head unless you're really that good. But using dimensional analysis, it's a really easy question. 17 inches, here's my given. Multiply, here's my fraction bar. I'm looking for feet, so that goes on top. I'm given inches, that goes on the bottom. I now populate my numbers in the proper places on the fraction bar. My units will cancel out. Inches will cancel out with inches. I'll be left with feet. So 17 times 1 divided by 12 got me my answer, 1.42 feet. So let's try another example here. How many feet are in 4.20 chains? And you're probably wondering, well, what the heck is a chain? Well, in my class, I offer a conversion chart. And here's an example of the conversion chart. I have one for metrics and I have one for English system. So there's several different things. Many of these that we have here in the US, but we rarely ever use. So example, furlongs, and here we got chains and rods and phantoms and yards, coulombs, casks, various different units that are what we call in the English system of measurements. Well, the one I need here is 66 feet is 1 chain. So I need that conversion factor right there. 66 feet is 1 chain. So now that I know that, I can solve this question quite easily. So 66 feet, I'm going to write down here. Oops, is 1 chain. Just to write so I don't forget about it. Okay, so I'm given 4.20 chains. Okay, multiply fraction bar. I'm looking for feet. That'll go on top. I'm given chains. That's going on the bottom. Again, I'm making sure my units cancel out. So chains will cancel out with chains. I know that one chain is 66 feet. My units are in the correct positions on the dimensional analysis. I do the math, and you should get 277 feet is my answer for this. So 4.20 times 66 divided by 1 gives me 277 feet. And I'm following sig fig rules in my calculations. All right, I would like you to try these two questions. I have the conversion chart there to the right. I would like you to try them out, click pause, try them out, and when you're ready, just start the video again and we'll go over them. All right, the first one is we have 14 cups and we want to go to ounces. So I'm given 14 cups, multiply fraction bar. I'm looking for ounces, so that goes on top. I'm given the cups, that goes on the bottom. I gotta look for cups in ounces here. So 8 ounces is 1 cup right there. So 8 ounces is 1 cup. So that's my numbers are in the right spots. My units will cancel out. 14 times 8 divided by 1 gives me my answer on my calculator is 112. But to follow sig fig rules, the answer could be 110 ounces on there. So 110 ounces for that. Okay, going from 14 gallons to hogsheads. Something out of Harry Potter. Whoops. So 14 ounces. So sorry, 14 gallons. Multiply fraction bar. So I have to find hogsheads to gallons, and one hogshead is 64 gallons. So one hogshead. So hogsheads goes on top. Gallons goes on the bottom. 64 gallons is one hogshead, so 64 goes on the bottom of this fraction bar, and 1 goes on top. My units will eventually cancel out. Gallons, I'm going to multiply 14 times 1 divided by 64. And I'm going to get my answer to be 0.22 hogsheads. Okay, the last one. I have 1,200 feet, and I want to go to furlong. So here's my given, 1,200.0 feet. Multiply fraction bar. Okay, I know my feet goes on the bottom, and my furlong goes on top. I gotta find feet to furlong, which is right here. 660 feet is 1 furlong. So 1 furlong is 660 feet. Okay, my setup is correct. Numbers are in the right places. Feet cancels out. So 1,200 times 1 divided by 660, and I get an answer to be 1.8182 furlong on that. Box my answers. Here we go. Okay, dimensional analysis, those are just basically questions that are one conversion factor problems, but dimensional analysis, you can daisy chain them. So, for example, how many seconds are in 3.5 hours? So, here's some information that we need to know is that I'm going to write down. Now, I know that there are 60 seconds in 1 minute. I also know that there are 60 minutes is 1 hour. So, I have conversions for both of these. I'm going to what we call just chain them together. So, I'm going to write my given 3.5 hours. Multiply fraction bar. Okay, I gotta make sure my hours are on the bottom because they have to cancel out. And I'm gonna use this one first. 1 hour is 60 minutes. So I'm going from hours to minutes, but the question is asking for seconds. So I'm gonna chain this. Since I'm given hours here, my hours will cancel out. Now I'm left with minutes, but I have to make sure my minutes cancel out. So that means I have to write minutes on the bottom of the fraction bar so it'll cancel out. And I'm going to left with seconds on the top of the fraction bar. My minutes will eventually cancel out. And I know that 1 minute is 60 seconds for that. So I have basically a dimensional analysis where I'm using two conversion factors and I make sure the units cancel out. So hours cancels out with hours, minutes cancels out with minutes. I'll be left with seconds. My numbers are in the correct locations on the dimensional analysis. It's always important to double check. Now I just do the math. 3.5 times 60 divide by 1 divide by 1, and I get an answer to be, putting this in my calculator, 12,600, but following sig fig rules, it'll be 13,000 seconds after sig fig rules apply will be my answer. Dimensional analysis can also work with numbers that has to do with 2 units. So for example, how many kilometers per minute is in 60 miles per hour? So given 60 miles per 1 hour, now I'm going to use dimensional analysis again, and I'm going to be converting 2 units at once. I'm first going to do miles. So since miles is on top, I have to have miles in the bottom, and I have to find the conversion between miles and kilometers. And 1 mile is 1.6 kilometers. Okay, so I looked at my conversion chart. 1 mile is 1.6 kilometers. So converting my miles into kilometers is done. But now I have to, so miles is done. Whoops, miles is done. But now I got to convert hours to minutes. So multiply fraction bar. Now my hours is on the bottom here. That means I have to put hours on top to cancel it out. And I'm looking for minutes on the bottom. Just looking for minutes. So it actually works out quite nice. I know that 1 hour is 60 minutes. So there we go. My hours will now cancel out. I'll be left with minutes and I'll left with kilometers when I'm done. So 60 times 1.6 times 1 divided by 1 divided by 1 divided by 60, it comes out to be a nice easy number to calculate. It'll be 1.6 kilometers per minute. All right, there you go.